coming in, joining in, I think, for the evening session. Um, and thanks to the CNCF Foundation for allowing me to come here and present to you on Open Data Hub. How many of you have worked on Open Data Hub here? Or heard about Open Data Hub? OK, then I think you're in the right room, because you need to know that. OK, so I'm from Red Hat. I'm a senior principal architect, focused predominantly on OpenShift AI. That's a product which we have from, which is the upstream is Open Data Hub, basically. Okay, and then we have used that to create a product. So I'm not going to talk about Red Hat product as such. Let's focus on the solution which I want to talk through, okay, and the Open Data Hub, and how it is used in another open source product called OpenShift Lightspeed as well, okay, with an integration of RAG, LLM, and the platform which we have. I'm also going to talk about a couple of personas, like admin persona, on how an administrator can actually set up a data science pipeline, okay, if they already have a pipeline available with them, right? And the second persona is a data scientist persona. How many of you are data scientists or work with data? OK, cool. So, so what we do is we go to the workbench, and then we actually create a data science pipeline from there. And it will just run and get you what you are supposed to do, right, from the pipeline point of view. So again, so you don't have to worry about how it's going to run in the backend, right, as a data scientist. So that's the whole purpose of what I'm going to try and show through Open Data Hub here. And yeah, that's and I'm going to use generative AI as a framework or an example here. I'm going to use a lot of tools like Argo CD, which I have used to deploy the whole environment in our lab. I am going to use Tekton or Argo Flow. Okay, these are all the workflows for the pipelines to be created from the data science point of view. I'm going to use Kubernetes as a platform, but I'm using OpenShift in this case. Okay, and then I'm using LangChain tool basically to create. I'm using to do embeddings and things like that. For now, in this environment, I'm using Postgres database with the vector extensions, but of course, you can use Milvus as well. And there are a lot of examples where if you don't want to have persistent storage, you can have in-memory database as well. Some of them work very fast in terms of getting the embeddings into the in-memory database and then showing it to LLM to actually get you what you need. I'll explain those things as well while we go through the process. But I would like to just, how many of you are implementing generative AI in your organization or thinking of, right? Everyone, right? Most of you. Fantastic. OK. Now, so what happens, right? We talk about LLM, large language models. We'll talk about RAG a bit. We'll talk about high-level architecture, which I view, like from my perspective, benefits of RAG approach, and then how to customize an LLM using RAG. We'll talk about Open Data Hub. It's an open source project, and it's actually an AI platform, a very beautiful platform for you to actually go and understand and use it in your environment. Then I want to focus more on the demo part here, demonstration. I'm thinking of doing live demos. I have some tabs here in my browser available. In case if it doesn't work, at least I'll show you that. Hopefully it works here. Then I can show a little bit more about, we can dive a little deeper into what things are deployed as, right, from this specific solution point of view. Yeah, you can think this as a base model for you to do your development testing, okay, of a generative AI with RAG and or a simple chatbot if you want to create. Okay, and then it can be like a first step for you to go and understand how things work, right, how things are integrated. And then you can eventually improvise on that, get better tool sets, get a better embedding algorithms based on your requirements, or better LLMs. So we'll discuss those few things as well here, right? Now, what is RAG? It's basically a technique that enhances the capabilities of LLM, right? So if you know, LLMs are basically using set of data and are trained on those specific data sets. Now, if you want to use an LLM within your organization working on your data sets, right? it doesn't understand because it's not trained on your data set, until you do a fine-tuning of those models using your data sets. So far, I have spoken about 3 different terms, right? Okay, I have spoken about what? RAG, with embeddings in it, right? So that's where you actually split your specific domain data and store it in a vector database, okay, which is like embeddings. Second thing I spoke about is fine-tuning, right? Basically, let's say you have a base model or a base large language model. You peel few of the upper layers from the neural network, create your own safe tensors out of that, and basically you push that back into your S3 bucket, right? And then you deploy your models using that. That's fine-tuning. Again, in fine-tuning, you can use your data sets. For example, we have something called Instruct Lab. Now, in Instruct Lab, you can do a Q&A, right? You can provide a set of questions and answers to that. And so it's like, let's say, a sample of 5 questions and answers from your specific domain, or 10 or 20. And then use a synthetic data generator, which can help you generate large amount of information based on those question sets. And then you can expose that to fine-tune your base model. It can be a Granite model, it can be a Llama model, or depending on what you want to use for your specific domain set. Now, this is what I'm talking about, is file tuning, where it actually goes and add those specific tensors into your existing framework, right, of the model. And the third scenario, which a lot of enterprise would like to avoid, is to do a complete scratch training, right, on your specific data sets. But so, for example, Llama model, right, 80 billion parameters model. So many big, huge models are there, right? So to train those models, it takes like a lot of CPUs and a lot of resources and days, right? It's very costly affair. So that's why the fine-tuning works. Okay. Fine-tuning also, you cannot do like every day, right? If your data keeps changing, and you need to have a chatbot which reflects and responses to the data which is immediately like changed, right? Okay, for example, today. And I want to have that information in my chatbot tomorrow. The embedding is a good way to actually push the data, everyday data, or you can decide a frequency. Fine-tuning is the next stage. So you define when you want to, what frequency you want to do fine-tuning. And the training is something, if you cannot avoid, okay, try to do a training, also define a frequency. The cost matters, right? The time matters, and your resources and the data scientist team also matters, right? And for doing different type of scenarios. So that's the 3 different terms I wanted to define, basically embeddings, fine-tuning, and training. Right. Now, what we are talking about here is RAG, Retrieval-Augmented Generation, right? So it's basically, it augments LLM knowledge, right, with your domain-specific knowledge in your environment. Now, if you see on the right side, is that visible? I think, is it visible at the end, the picture? Okay, cool, great. You guys have good eyes. Even for me, it's not visible properly. So let's see if this is working. No, it's not. So basically, I'm giving you a chatbot example. So you have a Gradio, which is a UI. In our case, we can do anything, like we can do Stimulate or any other application. It goes, basically, you have a query. Now, whatever is your embeddings, you're stored in vector database. Anyone uses vector database so far, or RAG? Okay. General trend, like, do you guys, just show me a hand if you guys are using Milvus? Okay. Postgres with the vector extensions? Oh, many of them Postgres with vector. Any other, like Redis? Okay, cool. In-memory database? Redis, right? Okay, cool. So all those things go into a vector database as embeddings. And then, let's say you have a question. It goes into prompt template. Prompt template is where you actually say, okay, you are a very sincere, domain-specific knowledge expert to the LLM, and that guy will respond to you on that specific context, right? And then you provide your embeddings. So basically, embeddings, you have the syntax and the semantics, everything going into embeddings. It also understands it basically does a similarity search based on what query you are having. Okay. Some of the embeddings use cosine search. There are different ways, basically. And you can use different types of embeddings. That matters for depending what your data set is. So you need to be careful about selecting embeddings and how do you do text splitting, whether the chunk sizes are fine or not, right? Okay, and what is the best chunk size for your specific data sets. So those things have to be defined before you actually move your data into vector database. Then once the data is there, the embeddings, the similarity search will be done based on what your query is from the chatbot and what the vector database data is coming out from. That information, along with the prompt template, goes to LLM, and then you get an answer based on your context or your domain-specific information, right? So that's the basic architecture. Let me move quickly. Again, LLMs are powerful, but their knowledge is limited to what they are trained on, right? So we use RAG to get your domain-specific information. Again, some of the hallucination aspects are avoided because of RAG. So that's also an important aspect which you need to take care of. There are other few important pointers here as well. Like RAG is low cost compared to the time-consuming LLM models. So it doesn't mean that I'm not saying that you shouldn't do training or tuning or embeddings, right? You should basically figure out what is the best. All three might be best approach for you, okay, but then define on the frequencies and the cost associated with that and the resources you have. Now this is how the first part works, where basically you load your data. So you can actually take any documents or you can go and pull data from websites, right? Split your data, there are a lot of text splitters available. Figure out what is the best text splitter for your specific requirements. Define the chunks. Okay, store that in a vector database. A choice of vector database is also important, right? Because over time, your RAG database grows, right, the vector database. So you need to basically figure out how you want to do that. And then this is a process, right? Basically load, split, embed, and store. And once you have this in vector database, so far there's nothing to do with LLM, right? You can just use vector database to query and then get information, right? But it will be not in a way which an LLM is able to like generate and give it to you, right? It's more of it will just do statistical analysis of the data which you are passing as a query with what it has in vector database, compare with some numbers, using some specific modeling techniques, and then provide you outcome, right? Now that goes as that is the information which is retrieved, right? In the next part, remember the first diagram I showed. So what happens is when the question, when there is an input question, okay, or a query which goes in. Basically, it goes into your vector database. The data, it retrieves the information, gets to a prompt, and that query goes to an LLM, and it generates an output answer, right? So that's a simple high-level architecture. Some of the business benefits, these can also be use case in your organizations, right? Like content creation, there is personalized recommendations. So recommendation engine has already been there, right, for ages. But that is more about predictive, right? But you can use that in combination with LLM to do a generative AI as well for your recommendations to your internal folks or to your customers. Then there's automated data analysis. You can do efficient knowledge management, very important. A lot of operations team, they can actually push a lot of their logs with the results and the solutions they had, right, into their vector database, and they can use an LLM to query it. Okay, so there is an OpenShift Lightspeed, the project, open source project again. There we are actually using, we send the context, let's say on Kubernetes Platform, I have a chatbot running. It connects to my LLM in the backend. Okay, I can define which LLM I want to connect to. And then I query it, send the pod logs along with that, send the pod YAML status along with that. And that is the context it sets, right? It goes and queries the LLM. It does Llama index and has some local vector database as well. Or you can have your own vector database if you want to consistently store that and have your own knowledge base, right? And then you get a response giving you an answer on what you need to do to fix that issue, right, on the specific pod. So that's OpenShift Lightspeed. If you have time, I'll show you that as well. I have a tab on that. Yeah, and so about Open Data Hub, you go to opendatahub.io. So this is the project, which is an open source project Basically, what is Open Data Hub? It's an AI platform designed for the hybrid cloud, right? I mean, it works on OpenShift, and OpenShift is like, again, works on hybrid cloud, right? You can deploy OpenShift anywhere. So the same thing goes with Open Data Hub as well. It helps provide you tools for your training, your serving, as well as monitoring machine language learning models on-site, in public cloud, or at the edge, right? Now, the data scientist, it offers a lot of things. I can show you the UI as well. That will be better, actually. But yeah, it's meant for the data scientists, MLOps engineers. They can collaborate on this, do experimentation, ensure that they actually deploy the model in production here, and then it scales, right, for them. So there are runtimes like VLLM runtime, which we use here. That's the runtime which works along with. So there are many runtimes which are supported. Like there's an Intel OpenVINO runtime which we support as well. We support single model deployment on the Open Data Hub. There is multi-model deployment as well, depending on what models you are deploying. Generally, LLMs very big, right? Most of the time, you will in a single project in OpenShift or in data science, you will actually deploy a single LLM model. It also helps to infuse, AI-infused applications, right? You can actually build a lot of them very quickly and work with on the specific platform. This is how it looks like, basically, from the blocks. If you see, there's a hybrid cloud. You have Kubernetes. Then you have the Open Data Hub operator, which runs on Kubernetes. And that operator is responsible for deploying and maintaining all the components which are associated with Open Data Hub. Then on top of that, you have monitoring, alerting. You also have notebook controller, which is mostly the workbench, which the data scientists go and work on. You will have model serving and data science pipelines. Model serving is where you store your model and it can be served. And there is data science pipeline. This is predominantly focused on you as a data scientist or administrator can create your own data science pipelines depending on what your workflow is, whether you want to do data pre-processing, whether you want to do training, whether you want to do model deployment, or all sort of things, right? The complete pipeline flow. And then there is a very beautiful UI available for the dashboard. And you can leverage storage, right? And for example, we can actually do Open Data Foundation here as a storage, which provides you with S3, which provides you with block device as well. So depending on your persistent storage requirements, you can actually do a set of PVCs on Kubernetes, leveraging the OpenShift Data Foundation. Again, that is based on Ceph storage for the container platforms, right, or the application platforms. So that, again, is open source and available for you to actually consume. Anyone uses Ceph storage here? Yeah? OK, cool. There are a few. Nice to see that. Right, so that's about Open Data Hub. Basically, I wanted to show you a basic RAG implementation, understand how the data ingestion happens. OK, and you can use automation for the pipelines, review how the RAG and LLM can be used as an AI assist with OpenShift Lightspeed. So basically, I'm talking about two things. One is how you create a RAG-specific implementation. And second is, if for a product company, how you can actually embed these kind of systems, right, into your product sets. So think from those two different perspectives here. And I have actually provided, there's a blog here, which if you want how this specific thing is implemented, there's a detailed blog provided here. Then there is a deployment manifest, which I have used to deploy this specific environment, which I am showing you from the LLM RAG point of view. So you can go to this. If you have OpenShift deployed with Open Data Hub, you can actually do an Argo bootstrap and call this manifest and deploy this whole scenario, which I am describing here, right? And it's all available. I mean, you can just go and access it. So this is the data science pipeline. Basically, I have a simple pipeline. Do a data ingestion. I query it. I see the response time for that. And then I summarize the results, right? That's the pipeline I have built here. OK, so what happens, right? I have this UI here. I think it was not, yeah. Basically, this is running using Gradio as a UI. If you see here, I am providing, I'm asking a specific question, right? Provide location of KubeCon India. Now, it doesn't actually give me an answer because this guy it doesn't have any context set, right? So what I do is I ingest the data. There's other LLM which I'm running. I ingest the data. I ask the same question, right? Basically, it is now able to tell me as where it is, and actually it gives me a link as well. So that's how I created this information using data ingestion, right? So basically, I'm providing the same query again here, right? And it kind of like gives me a good result. Now, if you see here, this is my workbench, right? Okay. I'm using LangChain here again. I'm using embeddings, vector store for storing. I'm using a PG vector database here. So let me restart this, I think. Sorry, I can't hear you.
Can we see the context of what you have used so that it was able to provide the answer?
Yeah, I created, what I did, I went to KubeCon, I created a PDF file, and then I pushed that PDF file along with the link. I will show you that in the workbench. So this is my Open Data Hub, basically, right? It's the same interface. So I have this OpenShift Data Science Pipeline projects here, and then each project will have multiple scenarios, right? For example, yeah. So it has data science pipeline, model serving, then there are a lot of things you can have from the notebook images, accelerator profiles, serving runtimes, and things like that, right? Okay. Yes, you can do Elastic as well. Yeah. I'm just opening this, guys. So while it's coming up, there is another scenario where if I, in the Jupyter Hub, so this is my Jupyter Hub workbench. Basically, I can go here, and what I do is I'll, let's say in this case, I want to provide a product-specific version information, right? So I connect with my vector database here. I will set up the database collection name here from the vector database point of view, call in all my LangChain specific framework libraries. This is where I'm actually passing the PDF information, okay? I can either pull it from the website, or I can store it locally, and then it will pull it locally from that, right? Okay, then I'm also having PDFs to URLs. Basically, I'm using this to download all the files and store it locally. I'm setting up my websites here. This is a more interesting part, right? Basically, I'm using recursive character text splitter here to split the PDF document or whatever I have. I define the chunk size and define the chunk overlaps, right? Chunk overlap is like out of 1024 characters, 40 will be overlapped, right, with the next chunk. So that's what the overlap size is in this case. And then basically, I split that, and this is what it shows me, right, as the split information. The second part is the Hugging Face embeddings is what I'm using here. So there are many embeddings here. There is actually, where is that? Right. There is a nice, yeah. This is where you can actually go to MTEB, that is Massive Text Embedding Benchmarks. Okay, it lists all the embedding models and basically their benchmarks. For the one which, in our case, we should actually see the retrieval. There is this retrieval average. Okay, this is what we should see from this specific use case point of view. Okay. And once we do that, we actually move all those embeddings into the database, okay, and then query it, right? So it basically gets into, and then we can have similarity search and those kind of specific parameters set here. Right. Now, so this is my Jupyter Hub notebook, right? Now imagine I have like, this is ingestion, then there is a query, there is response time, which I showed you, right? So basically I can go here. This is my Elira notebook. Elira editor. Basically, I can just drop these programs in here, connect with them, specify the input and output, and once I just say, once I run this right here, okay, using this, it will go and basically go to a specific pipeline and then run. I already have this executed here, okay, as the pipelines. So if you see here, these are all. So there are two ways. Either I can do it through Elira, so it shows me, right? Okay, as a data scientist, that's what you can do actually. Okay, and then you don't have to worry about how the pipeline gets created on the Kubernetes platform, scales, and runs and executes. You just have to worry about the outcome, right, for that. Then there is another way where you actually can import this pipeline. So I can actually import, say, test sanity check, and then I can go in here, and then I say, okay, this is what I'm importing, right? And then import. So this will actually create this import data ingestion pipeline, and then I can go and view my runs as well here, okay, whether it has completed or not. Yes. See, its status was green here for that. Now, there is another aspect to that, which I wanted to show you. Yeah. Was that here in the data science pipeline, right? If you go here in the edit, so it actually supports two different pipelines here. It either supports Argo Flow here, or it supports Tekton. So these are the two pipelines which it supports, data science pipelines. So you can use any of this basically, right? Either Argo or Tekton. So in the latest version, the flow, the movement is so the recommendation is to go and work through Argo Flow, but you can still use Tekton as well. So both are available for now. And now what we are doing, I think I'm almost through with this. So this is my OpenShift Lightspeed architecture. So that was about the LLM and how it sits. Sorry, I want to show more in terms of how it's deployed, but because of the time, I couldn't do it. So this is our OpenShift Virtual Assist leveraging the RAG with LLM. So you see there is a RAG database which can be associated. There's an LLM which is there, which is outside of your OpenShift Lightspeed, right? And it just has connectivity with your backend LLM. And then it goes into a corporate VPN where you have more information about how the things are from your specific environment point of view. There's OpenShift Virtual Assistant. Basically, it helps you ease your user productivity, increases ease of use, increase productivity, and generative AI. So this, you can use it in your OpenShift environment, right? And this is how basically it looks like. Where is that? Yeah. So I have this broken pod here, right? This prod is not working in my OpenShift environment. So basically, I can say, OK, ask OpenShift Lightspeed. So it will go to this chatbot, and I'm saying, OK, what is broken in this pod? And please provide a fix for it, right? I'm sending it into context. So it goes and sends the YAML status to this, right? I can actually send additional information, like I can send logs as well to that, right? Through this logs, events, YAML status. And it will actually go and give you a fantastic output as well as figure out. So in this case, basically it's saying why the prod is broken. And then it says, OK, what you need to do to fix the issue, right? So this is how you can use assistant, right? AI-based assistant to actually help you fix your issues in your OpenShift environment, right? And so, yeah, that's what I wanted to show here as part of my presentation for now. And yeah, I think we have 1 more minute for query or question. I think 4 more minutes. OK, we start with.
Yeah. Could you use your organization's knowledge here? I saw that you just passed the YAML file, YAML status file, but if you have incidents which are resolved similar to you, how could you pass that on?
Oh, what you can do is you can have a RAG database associated with that. Okay, and you can store that as embeddings in RAG database. And then you configure in such a way that it will go and pull the context from the RAG database along with same approach would matter. Yeah, because we have a support, it works with RAG as well, yes. You can, what do you mean multiple embeddings?
One is maybe your log files, and the second would be, the log files are one.
Yes, yes. So log file here, in this case, I'm sending it through the context itself, okay, and that becomes a chat query. And then I am actually, along with that, you can actually do a RAG as well. Okay, is what I am thinking of. Yeah. Sorry, yeah? Here, when you select a specific embedding, okay, and you push it into vector database, it will do indexing for you. Yes, automatic. But you can, if you want to have proper indexing, right, you can use your own indexing, like Llama index you can use, or some other mechanisms you can use to have proper indexing done as well. Yeah, yeah, sorry.
What was your logic behind chunk overlap and chunk size? Why it's 1024?
There's no logic in this case. You need to basically try it out in your environment and see what is the best suitable chunk size and the overlap size for your specific data. Yeah, you are. Yes. No, actually they are very different. It's a platform, AI platform. Whereas NIM, you can actually deploy it on Open Data Hub, okay, as a runtime. So we have different single model deployment, multi-model deployment. You can have a NIM deployment also in that. Okay, same way. And it has a runtime as well. And then in that, you can actually select, when you deploy, do the NIM. You can actually enable NIM if you have enterprise license on this. And you can go and download your NIM model, whatever model is supported in that NIM. Or if you don't want to do this, you can just do a NIM deployment on OpenShift, basically. Either of that is possible. Sorry, any other questions? Yeah, sorry. I'll take. I can't hear you. How are you doing? Similarity check. That is actually being done by the same embedding, right? The Hugging Face embedding, which I use to push the data into vector data, I use the same. Okay, when I'm doing extracting. So basically, whatever is the logic in that specific embedding model, it will actually use that logic. Okay, so most of them, I think, some of them use cosine similarities. Okay. Yes.
This is really powerful for incident management.
Yes.
Any organization using it?
Right now, all the organizations are trying to figure out how to basically push the data into vector database and then try and see, because just an LLM will not help. So you need to have a RAG database. Build a RAG database, that should be your own IP, basically. Okay, and then play around, basically, with that. Okay, that's the best way to do.
Using generative AI for incident management.
Yes.
It's not yet.
Yeah, people are exploring that. A lot of customers are exploring. Yeah, enterprises are exploring that. Yeah. Okay, but this is a platform which can help actually do a lot of things for you on that, from that point of view. Okay. Yes, last question. Okay, so I actually showed you two different environments. One was running with Kubeflow, one was running with Tekton. Okay, the older version has only Tekton. The newer one has both Kubeflow and Tekton. I can have it, yeah, either of that. Okay. Frankly, I still need to figure out the differences between what will be better in what scenarios. Okay, generally, I see the MLOps flow from the app dev point of view. Tekton is better. From the data science pipeline point of view, the Argo flow has a lot of scenarios which actually helps to fine-tune, train, or experiment, those kind of things. Okay, it has very good integration with that. Basically. Yeah, so Argo Flow is part of Argo Flow. Basically, you can define the services in Open Data Hub, and those services will be enabled on your OpenShift if you have those operators installed, like Tekton, okay, or Argo, those kind of things. Okay, I think time is over, and we need to clear off the stage, at least for myself. We can do an offline discussion. Yeah. Thank you for joining. Have a good day.